Section 7.3 talks about simple interest. When a person gets a loan from the bank, that person has to pay back the amount of loan plus interest. The interest is a fee that the person has to pay for using money from the bank. In the same way, if a person opens a savings account, the bank pays that person interest since the bank gets to use that person's money while it's in the account. The formula for simple interest is I equals PRT. The interest I is the fee paid for borrowing money. The amount of the loan or the amount of the savings account is called the principal, P. The interest rate, R, is the rate that interest is charged on the amount borrowed converted to a decimal or fraction. The interest rate is usually given as a percentage and is assumed to be a yearly, or we say annual, percentage unless it states otherwise. The amount of time T is the length of time the loan in years. Now, if an instance where the interest rate is given as a monthly interest rate or as a daily interest rate, then corresponding the time would have to be in months or in days. Your units have to be consistent. The amount A that is paid back is the principal plus interest. So we say A equals P plus I. Now, many financial institutions do not like the fact that the number of days in the month is inconsistent. Some months have 31 days, some have 30, some have 28 days, and occasionally there's a month that has 29 days. To avoid these inconsistencies, banks will assume that there are 30 days in a month. As a consequence, they will assume that there are 12 times 30 or 360 days in a year, as opposed to 365, or in the case of a leap year, 366 days. This is known as banker's rule. So 1 month equals 30 days, 1 year equals 12 months equals 360 days. As you can imagine, there is a potential for great confusion between financial institutions and the consumers, since each has a different definition of what a month is. To avoid confusion, many times these institutions will state the length of time in days rather than months. For example, many stores may offer 90 days same as cash instead of 3 months same as cash, since the 3 months to a financial institution is not the same as 3 months for a consumer. By offering it days, everyone understands the exact length being discussed. So it's always important to read the fine print. Now, let's go ahead and try some examples. So we'll go head to our workbook. We're on the middle of page 105. And we're going to take a look at the first example. Max borrowed $4,500 at 6% simple interest for 2 years. What was the interest he had to pay and the total amount he had to pay back? Alright, so we're doing our simple interest. I equals PRT. So our principal here is the $4,500. Our R here is 6%, but I need to write that as a decimal. So slide the decimal over 2 places. And our T here is in years, which is 2. So we're going to go ahead and plug into our formula. So we're taking the 4,500 times the 0.06 times 2. Alright, so let's calculate that. 4,500 parentheses 0.06 parentheses 2. So that'd be $540. So that'd be an interest. Now, is that what they want? Yeah, they want the amount he paid in interest, and they also want the total amount he paid back. All right, we need to get that too. So A equals P plus I. So that'd be 4,500 plus 540. That would give us $5,040. And this would be the amount paid back. All right, let's try the next one. Alicia had a loan of $600 at 7.8 simple interest for 120 days. How much did she have to pay back? So we have our P here is 600. Our R here, again, got to write that as a decimal, so it's going to be 0.078. Now we have to be careful with our time. Here's where we're going to have to use Banker's rule. I'm going to have to divide that 120 by 360. I'm not going to use 365 because I'm using Banker's rule here. So we'll calculate our interest. That's going to be 600 times our value for R times our value for T. Now we can enter that exactly how it's written. So here's what we're going to do. Clear the screen. I'm going to type 600 parentheses 0.078, close them off, open up again, hit my fraction key. Now I'm going to do 120 over 360. I'm going to hit my right arrow key to get out from that denominator, close off the parentheses, enter. So that's 15.6. We're talking about money, so that's $15.60. So the total amount she had to pay back would be 600 plus $15.60. So that'd be $615.60. Now let's go back to our handout. We got to talk about using the future value formula. The amount a person has to pay back, A equals P plus I. Since I equals PRT, we can rewrite this as A equals P plus I as P plus PRT. Now the formula usually will see it written as P parentheses 1 plus RT. In fact, if I distribute the P times 1 is P times RT is PRT. So it's an equivalent formula. So amount to be paid back, A, is called the future value, and the principal P is called the present value. So the future value for simple interest, the future value of A, of P dollars at a simple interest rate R as a decimal for T years is given by A equals P times 1 plus RT. So like we did previously in problem number 2, we had to first calculate interest and add it on. Now we can do it all in one fell swoop. A loan of $3,500 is made at a simple interest rate of 4.5% for 3 months. Find the loan's future value. So I'm going to write down the formula. And by the way, look on your yellow formula sheet. All these formulas that we're going to be using this chapter come from the front side of your formula sheet, and you will have a copy of that when you take the test. So make sure you have that yellow formula sheet that I gave you at the beginning of the semester handy for these problems. So my P here is the 3,500. My interest, again, I got to write that as a decimal, 0.045. And now my time here is 3 months. Well, that's 3 over 12 because there's 12 months in a year. Now we can then plug that all in the calculator. That's what we love this calculator. It just lets us to do everything. I don't have to worry about reducing that fraction or anything like that. Just type it in as is. And that's going to give me the answer. Now, we have a slight problem with this answer. Because notice that we get 0.375. We have not had fractions or half cents in this country since 1857. So we're going to have to round this off to the nearest cent. We cannot leave it in this form. So I'm going to go ahead and round it off to the nearest cent. Sometimes in MyLabs Plus they might want to have you round it off to the nearest dollar. In that case, you would say $3,539. So just read with the directions what they have. Let's try number 4. Alejandro borrowed $3,600 for 9 months. He paid back $3,863.25. What was the simple interest rate? So again, we're going to write down our formula. And let's plug in what we have. Okay, our principal is $3,600. Our amount paid back is $3,863.25. 1 plus. We don't know what the interest rate is. That's our unknown. And our time is 9 months, so I'm going to write that as 9/12. Now, you need to take a look at this and realize this is just solving a linear equation like we've done before. We got to first simplify each side of the equation. So that means we're going to need to distribute. Distribute that 3,600 to both terms. Well, 36 times 1 is just 3,600. And then we're going to do 3,600 times the 9/12. So that's 2,700. Or, oops, I meant to put that as lowercase r, sorry. So just using the distributive property, we're solving for r. So let's subtract 3,600 from both sides. That gives us $263.25 equals 2,700R. Let's divide both sides by 2,700R. Or sorry, try that again. We're going to divide both sides by 2,700. So that gives us 0.0975. Which would be 9.75%. So that would be the simple interest rate. Now let's compare that to example 5. Juanita had to repay $6,809.60 for the principal she borrowed at 7.2% for 3 years. How much was the principal? So this time we have R, we have T, we have A, we don't have P. So that's what we're looking for. So let's plug in what we've got. Here's our A value. $6,809.60. We don't know what P is, that's what we're looking for. And then what are we going to write down for R? 0.072. And our time here is 3 years. Now, notice the stuff inside that parentheses is all numbers, so I can simplify that. So I'm going to take my calculator here. See if I can squeeze it in here. 1 plus 0.072 times 3. It's 1.216. So to solve for P, I need to divide both sides by that 1.216. So that gives us $5,600. All right, so let's do one more example. Mike received a payday loan of $260. If at the end of 4 weeks he paid off his balance of $328.26, what was his annual simple interest rate of the loan? So this is a lot like problem number 4 we just did. So our A value here is going to be $328.26. Our P value is $260. We don't know what R is. T is 4 weeks. Well, there's 52 weeks in a year, so we're going to have to divide that by 52. So if it's not given in years, whatever unit of time divided by the number of units, you need to make a whole year. And if Banker rule applies, then you have to use the values from Banker's rule. So, like we did in problem 4, we're going to distribute that 260 to both terms. So this would be 260 plus, we'll take 260 times a fraction, 4 over 52, and that will give us 20. We'll subtract 260 from both sides. So we do that, it gives us $68.26 equals 20R. Oh, kind of fell off there a little bit. And then we're going to divide by 20. Gives you R equals 3.413. Remember, this is in decimal form. We got to change it to percent. So when we do that, that becomes 341.3%. That's a god-awful interest rate. And actually, what the state of Texas has done, they've limited the interest rate that payday loans can pay. So what they do is they just charge a fee, a processing fee or application fee. And that's how they get around it. Now, the problem with these simple interest problems, they're not really very realistic, because the assumption with simple interest is you're not making any payments over the entire length of the loan until the very end. Whereas normally that doesn't happen. We may make weekly or monthly payments. Also, assume that the interest does not accumulate or compound on itself as well. So the next few sections in Chapter 7, we're going to be addressing those issues.